What's up, guys? It's Taylor. Welcome back to The Blueprint, a channel in which we talk about software engineering principles and sometimes I build things like today. Today we're actually going to be building a tic-tac-toe game in the console in Java against a computer player. Now, if that sounds like something you're interested in, or you just need help with your homework, I got you. This tutorial is going to be super simple. I'm going to explain everything, each step of the way, and I'm going to make sure that I use very simple, obvious logic so that you know what's happening in the program. So, as always, the timestamps are going to be in the description box below, and let's get started. Let's be frank here. You probably just want to start coding, but I think we should create a game plan to keep ourselves organized and make this task a lot easier for ourselves. Here's my suggestion. I think the first thing that we probably should do is to figure out how to create a board and then print that board out. Then once we've mastered that, then we should probably place one piece on the board and then another piece on the board and then another piece on the board. And then I feel like we should figure out how the computer is going to place pieces and the logic behind that. Then once we've mastered those things, we actually need to do some sort of validation to make sure that we're moving in valid locations and that the computer is moving in valid locations. Then once we've done that, we need to figure out the game state, meaning has the computer won the game, have we won the game, or is it a tie? Once we've done all of that, we're going to package everything up in a nice juicy loop so that it actually feels like a game, and then we should probably keep score for fun. So that's just a general flow of what we're going to do. So let's get started. How are we going to create a game board?
So if we think about a traditional tic-tac-toe board, it looks something like a hashtag. 2 parallel vertical lines and 2 parallel horizontal lines. And if we think about what we know about Java, there's nothing that really looks exactly like this. So we're going to have to use a little bit of creativity in order to create a game board. So my first thought is let's use a 2D array. But rather than using numbers or booleans or things like that, maybe we can actually just use a char array. So it is going to require you to maybe stretch your mind a little bit. But I think we can come up with something that will look something like this. You know, it's made up of some dashes, some spaces, and vertical bars, but essentially it gets the job done, and it is a tic-tac-toe board. How we would create this step by step would be to create a dash, a vertical bar, another dash, another vertical bar, and another dash, and that would be our first row. Our second row would then be created with a dash, a vertical bar, another dash, another vertical bar, and then finally another dash. Our last row is going to be a little bit different, but it's actually going to be created with a space, a vertical bar, another space, and another vertical bar. So this actually gets us something that looks similar to a tic-tac-toe board. So now that we figured out essentially how our board is going to look, we should probably figure out how we're going to keep track of everything in our board since we're using chars and this is a char array. I think the easiest way to do this would to actually be to create positions. So what I mean by this is that we assign the numbers 1 through 9 to the different positions in the char array. So for example, position 1 is actually at 0, 0, and then position 2 would be at 0, 2, and position 3 would be at 0, 4. So let's actually look at the code to see what it would actually be like to construct this array and to actually print this out.
I'm just going to go ahead and create some helpful notes up here. We already know that we're going to be creating our game board out of dashes and vertical bars. So I'm just going to go ahead and create a simple little diagram here of what our tic-tac-toe board is going to look like. I'm also going to go ahead and list the indices because these will come in handy as we're writing our logic down. So we have the positions 1, 2, 3, 4, 5, 6, 7, 8, and 9. And these are going to be represented by 0, 0, 0, 2, 0, 4, 1, 0, 1, 2, 1, 4, and 2, 0, 2, 2, and 2, 4. These are going to represent the positions 1 through 9. So the very first thing that we're going to do is actually create our char array. And this is going to be a 2D array with 3 rows, which are going to be represented by dashes, vertical bars, and spaces. So the next thing that we're going to do is to create a method that is going to print out our 2D char array. We're going to utilize 2 for each loops to do this. Our very first for each loop is going to say for each row inside the 2D array. In our next for each loop, we're going to say for each character inside of the row. And inside of this for loop, we're going to say print out each char. We're going to exit out of this for loop, and then inside of the original for each loop, we're going to create a line once it's done. So what this is going to do is go through and print out an entire row, then print out a line, print out another entire row, print out a line, and then print out another entire row. This will ensure that all of our characters get printed out and that they're not all on the same line. So now that we figured out how to print the game board out, the next thing we probably should do is figure out how to place a piece on the game board. So if we kind of think about this a little bit, our array is a 2D char array, meaning that we can simply just use the array syntax to update the location that we want to place our piece and update that location from being a space or a dash to just being an X or an O. But I'm pretty lazy and I don't really want to write 2 methods for the computer and one for the player. So we probably should figure out a way in which we can create this method so that way we only have to write it once. My solution to this is that we give the player a number, like let's say 1, and then the computer number, let's say 2, and then we're going to feed this to our method, and we're going to use this to help us decide what character we should place, whether it should be an X or an O. So if we're doing something like this, I think we should probably create, let's say a switch statement. So we should probably create a switch statement depending on what number was given, such as 1 or 2, and then that switch statement will determine what we place inside of our array. And then once we do that, I think we can probably create another switch statement because we're keeping track of the positions, remember, 1 through 9. So if we feed our method the number 1 for the player, and then we also feed it the number 1 for a location, we can kind of construct something that would tell the computer, hey, at position 1, place an X. And then we can also kind of do the same thing for the computer moves probably as well. So we would then feed the method, hey, number 2 at position 2, which would then put the O characteristic in the position 0, 2. This is my logic as to how I think we can update the game board and place X's and O's interchangeably so we don't have to write 2 separate methods. So let's actually look at some code for this. Okay, so now that we have figured out how to create the board and how to print the board out, we need to actually figure out how to put a piece on the board. So using the logic that I talked about earlier, we're going to create a method that accepts an integer for the position 1 through 9, an integer for the player, which is going to be either 1 or 2, and then the game board itself. So we're going to create a character that is going to hold our symbol. So now we're going to create a switch statement that is going to switch dependent upon the player integer that was input into the method. If the player integer is equal to 1, then the symbol that we're going to use is X. If the player integer is not equal to 1 or equal to anything else other than 1, then it's going to be the O representing the computer. Now we're going to create a switch statement that is going to switch based on the positions. So earlier, I kind of posted those helpful indices. Now would be a good time to go and look at those because 1 through 9 represent different indices. So for example, 1 is actually 0, 0, 2 is actually 0, 2, and 3 is actually 0, 4. So how we're going to update our game board is that depending on what number was entered, the corresponding indices is going to be changed based on the character. So for example, if 1 is entered, then the game board 00 will be updated to match this symbol. So now I'm about to be super lazy and just copy this entire syntax all the way down, changing all of the necessary numbers. So for example, if the player or computer passes the number 2, then the position 02 should update to be either X or O, or if the player passes the number 3, then the position 04 should update to be X and O, so on and so forth. And I'm going to continue this logic all the way down for all 9 positions. And so now let's go ahead and test to make sure that this method works. So we're just actually going to test all of the positions with the player to make sure that we get that. So we should get 9 X's all the way across. And indeed we do. So it looks like our method works. So now that we have created our game board, figured out how to print our game board, and how to place a piece on our game board, now it is time to actually get player input. This part is really simple. We're just going to create a scanner class that is going to save the input from the user. So all we want to do is to ask the user to give us a number 1 through 9, because if you remember, 1 through 9 represent the different positions on our tic-tac-toe board. Once we have this number, whatever it is, 1 through 9, we're going to pass it to our update game board method, and then we're going to print the board out. Pretty simple. So let's go ahead and get our player move. Like I said, this one's really simple. We're just gonna prompt the player with some directions and get their input. We're just gonna create a scanner class, and then we're going to save the input that the player uses and pass that input into our update board function. Let's go ahead and test this out. So I'm just gonna give it like 2 and 5 and 4, and it looks like it works. But you'll notice something. I put 4 in twice and nothing really happened, but I shouldn't have even been able to put 4 in twice. So that means that we actually need to do some validation to make sure that players can't move wherever they want to. So now that we figured out how to place a piece on the board, let's just go ahead and handle validation right now to make our lives simpler. So there's 2 issues that can occur in our program. One is if we try to place a piece on top of our own piece, and 2, if we try to place a piece on top of the computer piece. And both of those things are not allowed in tic-tac-toe. So if we think about our code and how it's written so far, there are only 4 characters that are actually allowed on our game board: a space, a dash, an X, or an O. And in our game world, a dash or a space represents a value that has not been changed. So if we kind of think about this a little bit, if it's an X or if it's an O, it's a value that has been changed, and that position has been filled. If it's a dash or a space, then that position is empty. Now we can create some logic that would say something like, if the space is filled, meaning that it has an X or an O, then it's an invalid move because that space is filled. Else, if the position has a dash or a space, then the position is empty and it is a valid move. So we're gonna write something that looks a little something like that. But the question that you might ask is, what are we actually going to do with this method? So we're actually gonna update our, player method, and we're gonna change it. So once we get the input from the player as to what move they want to make, we're then going to take that move and test it against our validation method to see, is the move that the player is trying to make a valid move? And if it is, go ahead and update the board. If it is not, then we're going to prompt the player to actually input another move, and then we're going to test that move also against our validation method. And we're going to continue to do that until the player enters a correct move. So let's look at some code for this. So just like I stated earlier, we're going to create a method that is actually going to check to make sure that the player or computer move is valid. All this method is going to take is what integer for the move and the actual game board itself. This method is going to be a giant switch statement, switching on the number that the player or the computer entered. So all we're checking to see is if the game board location that was entered is empty, which for us is going to be either a dash or a space, depending on the actual indice. The first two rows are all dashes. The final row should be a space. If it is not either a dash or a space, that means that that location is filled and it is an invalid move. So I'm going to go through and create logic for every single case, such as case 1, case 2, case 3, case 4, and I'm just going to copy the logic from all the way down, changing the numbers as necessary. Okay, so like I alluded to earlier, we're going to have to go through and update our player input method. So what we're going to do is test the input that the player gives us against this method. If this method returns true, it's a valid move, no problem. Go ahead and update the board. If it's not, then we're going to wrap this whole thing in a nice juicy while loop and continue to prompt the player to give us another move until they actually give us a valid move. So let's go ahead and test this all out and see if this works. Now that we've validated our moves and make sure that we can actually move in correct locations, let's just go ahead and set up our computer character. So there's multiple ways to set up a computer character or computer player, whatever you want to call it. But I think the easiest way is to actually just use a random number generator. And so here's my logic behind this. Because our game board only allows the positions 1 through 9, we can just use a random number generator to just generate random numbers to simulate that a computer player is just placing pieces at these random locations. Now, is this a smart way to set up an AI? Maybe, maybe not. You know, that's beyond the scope of this. So essentially what we're going to do to create our computer player is to use the random number generator to generate a move, and then just like the player class, we're going to test that move against the isValidMove method to make sure that it is a valid move. If it is not a valid move, we're going to go ahead and generate another number until we find a valid move, and then once we find a valid move, we're just going to update that location with the computer piece. Pretty simple. This class is very similar to the player class, with the only difference really being is instead of a scanner input, we're going to be using a random number generator. And that's the entire logic behind the computer method. So let's see some code and see what that looks like. Let's go ahead and create the computer method. Now, like I already said earlier, this one's super simple. We're just going to create that random number generator and wrap it in the exact same code that we used for the player. So let's go ahead and test our code. So we're going to test the player code and the computer code to make sure that it is possible for us to move in every single location. So now that we have gotten the player movement, we have gotten the computer movement, and we validated that they are actually moving in spaces that they can actually move, we should probably figure out if our game has been won or not. So Tic Tac Toe actually has 8 winning conditions and 1 tie condition. So we have 3 horizontal winning conditions, 3 vertical conditions, and 2 diagonal conditions. So the logic for this is going to be kind of simple. If position 1, 3, and 5, let's say, all equal X, then player 1 has 1. And if, say, positions 1, 5, and 9 all are equal to O, that means the computer has 1. So we're just gonna pretty much write this whole thing out, a win condition for X and a win condition for O at every single win possibility. So that's gonna give us 16 different statements that we're going to write to represent our win conditions. But the most interesting one, I think, is actually the tie condition. And this logic is something we're gonna steal from the validate method. So just like in the validate method, we know that our empty spaces are our dashes and our actual spaces. So our tie condition can really just build on that logic. If every single win condition has already been checked and they're all not true, and every single position is filled with either an X or O and not a dash or a space, that means you have a tie. So this one's pretty simple, but I think it might be useful to actually see the code for this, so it'll make a little bit more sense. So now that we've validated our code, we just want to check the game state. So now we're going to create a method called isGameOver, and we're just going to pass the game board. And so essentially what we're checking here, like I said earlier, is if the rows are equal, if the columns are equal, if the diagonals are equal, or if it's a tie. So I'm just going to create literally like 16 or 17 if statements in here, and that may or may not be the best way to do it, but it's a very simple way. It's very easy for you guys to understand what's actually happening. So if position 1 is equal to position 2, which is equal to position 3, if all of those are equal to X, then player 1 wins. If position 1, position 3, if position 1, position 2, and position 3 are all equal to O, then the computer wins. Simple. I'm literally going to write this entire thing all the way down, copy pasta. That's it. Super simple. So our tie condition works is if you check every single condition before this condition and that every single condition is not equal to its empty state, that means that every single position has something in it and it's not its empty state, therefore it's a tie. Does that make sense? So what I'm actually doing right here is wrapping the entire code inside of a while loop that is dependent upon the variable called game over. So game over is initially set to false. And what game over is doing is checking to see if the game is actually over. So by wrapping this whole thing in there, we're going to let the player move, and then we're going to check if game is over. If game's over after the player moves, break out of the entire loop and end the game. And we're going to do the same thing. We're going to let the computer move and then check if game is over. If game is over, then break out of the entire loop. So game over is dependent upon the method is game over, which is our method to check the state of the game. So we're pretty much almost done here. All we really have to do is keep score. And this one's really easy to do. We're just going to create some variables to hold the player score and to hold the computer score, and we're going to update them every time the player wins or the computer wins. This is a super easy one to write. So now that we've checked the state of the game, well, now we want to keep score. So we're just going to create those two variables, like I told you, player score and computer score, and we're just going to increment player score or computer score depending on who's won. So what we're going to do is just going to open up our is game over method and just increment either player score or computer score. So all that's left is to make this actually a game. And so how we're going to do this is we're going to smash all of our code into a while loop. And we're going to create a variable called play again. So while play again is true, you're going to continue to loop through the entire code. And then once the game has been won, either the player has won or the computer has won, we're going to ask the player if they want to play again. And depending on what they say, yes or no, we're going to translate that yes or no into a true or a false. If it's true, play again remains true, and then the whole thing loops all over again. Or if play again becomes false, then we break out of all of our loops and the program ends. What I'm doing here is creating that large game loop called play again to make it actually feel like a game. So what I'm doing here is moving the scanner object outside of the player move method and putting it in the actual class. That way anyone can access the scanner method if they need it. The next part is super and simple. I want to consume what's already in the scanner method. Because what's in the scanner method right now is an integer. We don't need an integer. We actually need the input that the user is going to give us. So we're going to consume it. We're just going to skip it. We're going to eat it. We don't need it. Then we're going to say what the user is actually giving us. If that part of it didn't make sense as to why we had to eat it or why we have to consume it, I definitely suggest researching the scanner class a little bit more or just playing with it. Like if you're writing the exact same code, take that line out and see if the code still does what you think that it does. And then now I have to create a switch statement based on what the user has given me. Now, if you are using a more up-to-date version of Java, there is a different way to do this, and you are more than free to do that if you want to. But I'm using Java 11 right now, and I don't have access to the enhanced switch statement. So I'm going to write it this way, in which I'm saying if they give me an uppercase Y or a lowercase y, that means they want to play again. So if the user does want to play again, that means I need to set the value play again to be true, and then I need to set game over to actually be equal to false. And then eventually, we haven't wrote it yet, but I'm actually going to need to reset the game board. And then if it's no, then I'm just going to set play again equal to false and say thanks for playing and end it. So something that we still need to do is to actually reset the board. So what all we're simply going to do is create a simple method called reset board, which actually just resets every single position 1 through 9 back to their empty states. And now we just need to test our code to make sure we can get the player winning, the computer winning, and that we can get a tie. So, and now it looks like everything works. Awesome. And just like that, we built Tic Tac Toe in the console in Java with a computer player. So it wasn't too bad. All of the logic was super simple, and there's multiple ways on how you can improve this to make this game even better. I would love to hear your suggestions, or if you just want to talk, that's fine. Leave it all in the comments box below. Thanks for watching. You're still here. So I'm guessing that you kind of must like this sort of content. And if that's the case, you're in luck, because, I will in the future be doing more tutorials. But right now, this is the only one. However, I do have other videos that you can watch. Just down here, you can just go ahead and click on it and, be wowed by the other things that we do in Java. Or you could subscribe, that's your dealio too. You could subscribe to, or you could do both. It's totally up to you. There is no pressure. You can do whatever it is that you want to do. You can click wherever it is that you want to click. No judgment. We don't judge you.